All right. The last proof outside the Cartesian plane is the proof of the cos rule. Okay, and a question would be like this: use the diagram to prove that a squared is equal to b squared plus c squared minus 2bc cos squared. So probably the best thing to always do in all of these proofs is just filling in little a, b, and little c. Right? And then remember up here, okay, that if a vertex in front A is a question, you cannot construct a perpendicular height to that vertex. So we can't construct a perpendicular height to A. So we could construct a perpendicular height to B or to C. Looks easier to be able to construct the perpendicular height to C. So I'm going to make those right angles. Call that side equal to H for your perpendicular height. Right. Now the way that I always start the proof is I'm going to use Pythagoras, and I have to start with what I'm using in a right angle triangle. Okay. So I'm going to use here's A. A is part of this right angle triangle over here. So that's how I kind of start. So what am I starting with? I'm starting with A in that right triangle over there. A is a hypotenuse in that right angle triangle. So in working a triangle, let's call this D. In triangle BDC, we're going to have a squared, which is opposite the right angle triangle, is going to be equal to BD squared. And a squared is equal to BD squared plus H squared. Okay, so I've got the A squared into the formula. Okay, now it's a question of getting rid of the BD and the H and somehow getting it in terms of that. So that's just going to compile that. Okay. Right. Now I'm going to do a little sneaky trick. Okay. This distance BD is going to be equal to but BD is equal to the whole of this side C. So it's equal to little c minus AB. Okay. Trick we're going to have to use. So then to go sub BD into this formula over here, A squared is going to be equal to BD squared, which is little c minus AD squared, and plus H squared. Okay, so A squared is equal to C minus. Now you're going to square it out using the logic that x minus y squared is x squared minus 2xy plus y squared. So in this case, I'm going to square C minus AD. Then A squared is equal to C squared minus 2 times them together times by 2 minus 2C AD plus AD squared. And that's just that whole thing squared out plus H squared. Okay. Right. That's 2C80 plus 80 squared plus H squared. That is all right. Okay. So, but now, I want to get rid of, if I look at this diagram over here, sorry, lost my train of thought for a second. Now I'm going to look at the other right angle triangle, which is a right angle triangle that has AD squared and H squared in it. Okay. Well, if I have here's AD and here's H, so I could be working in that right angle triangle over there. So in this right angle triangle over here, okay. So in triangle ABC, you can see in triangle ABC that the hypotenuse B squared is equal to AD squared plus B squared is equal to AD squared plus H squared. Okay, and there we go. There's AD squared plus H squared. So in this formula here, okay, so I call this 1, over 2. I'm going to replace AB squared plus H squared over here with B squared. So if I sub 2 into 1, I have to write this, so to explain. I end up A squared is equal to C squared minus 2C AB. AB squared plus H squared is equal to B squared. So it's plus B squared. So look at what we're trying to prove. We're trying to prove A squared is equal to B squared plus C squared minus 2BC cos A. At the moment, I've got A squared is equal to B squared plus C squared minus 2C AB. Okay. What's the difference between these two? Well, the problem is I somehow have to replace AB with B cos A. Okay. So I need a right angle triangle that is AB at the side. So if I look at this right angle triangle once again, so in triangle ABC, okay, and I've got to get cos A into the sum. So in triangle ABC, okay, cos of angle A, or cos is equal to SOHCAHTOA, cos is equal to adjacent over hypotenuse. Okay, so cos of angle A is going to be equal to, well, here's angle A. The adjacent side, AB is your adjacent. So cos of angle A is equal to adjacent over hypotenuse. So cos of A is equal to the adjacent, which is AB, over the hypotenuse, which is B. So therefore, the times by B, B cos A is equal to AB, let's call that equation 3. Yeah. And we'll call this equation 4. So if I go sub 3 to 4, okay, if I sub 3 into 4, I end up with what? If I sub 3 into 4, I'm going to replace AD with B cos A, and I get A squared is equal to B squared plus C squared minus 2C, and instead of having AD, I'm going to replace AD with B cos A, and I'm going to get to the formula that I wanted. We end up with A squared is B squared plus C squared minus 2BC cos A. All right, guys. Hope that made sense. Go through it again, and then once again, I want you to look at this question over here, and if use the diagram to prove that R squared is B squared plus Q squared minus 2PQ powers are right. So go back. I want you to try and do this proof by yourself. Compare it to the answer we just did, and once you finish trying, come back and have a look at the video. Okay, so in this proof over here, well, once again, you cannot construct the right angle, the perpendicular height to whatever is in the question, so we can't construct it to R. So we could construct the perpendicular height to P or Q. Q is going to be the easiest. So let's call this T, and let's call that H. Okay, and these are right angles over here. What I should have done first is call this little P, call this little Q, that little R. Right? Okay, so remember, I said always start with the right angle triangle, and we have to use R squared in it. So the right angle triangle that has R squared in it is this blue one over here. R is the hypotenuse in triangle PQT. So proof in triangle PQT. Okay, the hypotenuse squared, which is R squared, right, is going to be equal to 8, is going to be equal to now. I'm going to have PT squared, so R squared is going to be equal to PT squared. Okay. R squared is going to be equal to PT squared plus H squared. All right. And then I do this thing over here, where I say that I know that PT, okay, but PT is equal to, I need to get Q into the sum, so it's equal to the whole of Q minus TR. Okay, PT is equal to the whole of Q minus TR. Okay, so therefore, okay, I can rewrite a sub integer and replace PT with Q minus TR. So I end up at R squared is equal to Q minus TR squared plus H squared. And I'm going to use the logic that A minus B squared is A squared minus 2AB plus B squared. Okay, so I end up with R squared, I'm going to square this out, is Q squared minus 2QTR plus TR squared plus H squared. Right, now, I look at what I was trying to prove. I've got the R squared, I've got the Q squared. Problem is some other mess. Okay, so the first thing I want to do is work out these last two terms over here. And remember, where's the right angle triangle with TR? Here's PR, and with H, here's H, right? Okay, so I can say, okay, but in triangle QTR, we got, okay, so the red one over here, in this red triangle over here, this is the hypotenuse, but in triangle QTR, T squared is equal to TR squared plus H squared, right? So if I put this equation 2 and then equation 1, and I sub 2 into 1, and to write the sub and stuff, okay, I can replace TR squared plus H squared just with P squared. So this whole thing over here becomes therefore R squared is equal to Q squared minus 2QTR plus, I replace TR squared plus H squared with P squared, so it's plus P squared. So I'm getting closer. Now in the formula, I've got R squared, I've got Q squared, I've got P squared. So if I want to rewrite that, so it's looking more recognizable, I get therefore R squared is equal to P squared plus Q squared minus 2QTR. Problem is, I've still got this TR over here. Okay, I want that TR, I want cos instead, right? Cos of angle R. So once again, I'm going to work in this triangle that's got angle R, right angle triangle with angle R. So here's angle R. Okay, this side TR is adjacent to R, and this side P, little p is the hypotenuse is opposite the right angle. Okay, so in triangle TQR, cos of angle R equal to adjacent R on the hypotenuse. The cos of R, what's adjacent to R? Adjacent to R is TR over H, the hypotenuse, which is little p. And hypotenuse adjacent over hypotenuse, which is at H. Okay, adjacent over hypotenuse, so the hypotenuse is over here, it's P. So there, times by P, I get P cos R is equal to TR. So let's call this equation 3, and that's 4. If I go sub 3 into 4, I can go replace the T. Okay, so into 4, I've got 4 is R squared is P squared plus Q squared minus 2Q. So I replace TR over here with P cos R. And R squared is P squared plus Q squared minus 2QP, or 2PQ cos R. So that is the proof of the Charles rule, and that's all 3 proofs done. Right. Thank you, Matrix.